Okay, and then today we're going to learn method 3 of graphing. This is going to be 3.4, and that's elimination. Solve by elimination. Okay, so we learned graphing, we learned substitution. Now elimination. We're going to make the 8 boxes of doom, the Hermsen special right there. Okay, and again we'll be using 4 spaces. You need workspace of 4 boxes for each problem. 3x plus 2y equals 1. 4x plus 3y equals -2. And our job is to find where those lines meet, the xy coordinate where they meet. Well, we don't have a variable by itself, and we don't need to. That's not how that's solving by substitution, where you have to get an x or y by itself. Okay. Elimination, here's what you do. You actually make lines and you make sure the x and the y are on the same side. Okay? And they are. You'll see that on all these problems, xy equals, xy equals, xy equals, xy equals, xy equals, and the rest of them go like that. So that's actually a good thing. We don't have to rearrange the equation. Now, we're going to eliminate either the x's or the y's from the system. I personally prefer to always do the x's, okay? So first what I need to try to do is try to get x and y to, or I need to get the same coefficient in front of the x. So we have a 3x here, a 4x here. We want to wind up with the same thing, okay? Hold on a second. Get the heck off my calendar, okay? So my parents have me watching this, are on a trip for their anniversary, and they brought their cats over to my house. So if you hear noise in the background, yeah, I'm not much of a cat guy, but I'm helping them out. They're kind of driving me nuts. Wish I could get a dog, but I'm not home enough to actually take care of it, okay? All right. So anyway, we want to get the same x's in front of the thing. So what I do here, I'm going to multiply the first equation by the x coefficient from the bottom. In this instance, it's a 4, so I'm going to take these all times 4. If you took Algebra 1 with me, we did this a lot. Then on the bottom, I also need to multiply the bottom. I'm going to multiply it by 3, okay? So 3, 3, 3. Okay, now 4 times 3x is 12x. I'm going to move over here. Plus 4 times 2y is 8y. Then 1 times 4 is 4. Now on the bottom we're going to have 12x plus 9y and then -6 because you're multiplying all by 3. Now what did that accomplish? Well, now you have the same coefficient in front of the x's. They're both 12s. But we want to make one of the 12s into the opposite so that the x's can cancel, because I always want to add, okay? Now, if you took Algebra with Miss P, I think she told you sometimes you could subtract, and you can. I always like to add. That's just my preferred method of doing it, okay? I'm not saying it's better, okay? That's just me. So 12 and 12 make 24, but if I multiply the bottom by -1, which means just change the signs, -9, +6. Now when I add the equations together, the x's go to 0. They're dropped out. So they're gone. 8 plus -9 is -1y, and then 4 plus 6 is 10. And then all I need to do is divide by -1, and y equals -10. Okay, now I got to find my x. Now what I like to do is go into the original system. You can actually use you can use this. You can use the equations after they've been multiplied. I personally like to use the original first equation, but that's just me. 3x plus 2y equals 1. And we have our answer for y. So I get rid of that, and it's -10. So we got 3x plus 2 times -10 equals 1. So 2 times -10 is -20. So I have 3x plus -20 or -20 equals 1. Then I add 20. Add 20, 3x equals 21, divide by 3, and x equals 7. So 7, -10 is a solution to that system. Okay, our next problem, I'm going to go over 5 more of those. Negative 2x plus 5y equals 15y, excuse me, equals negative 32. 7x minus 5y equals 17. Okay, so I'm solving for x and y. Okay, so again, the x's and the y's are lined up on the same side. That's the way you want it to use this elimination. So I personally prefer to drop the x's out. That's just me. So here I need to multiply the equations. So first the x's have matching coefficients. Now we're going to multiply by 7 on top. Now on the bottom, your top x coefficient is negative 2. I personally do not like to multiply by negatives. Okay, I don't when I'm doing this part of the problem. I like to multiply by just 2. So 7, 7, 7, 2, 2, 2. You could do negative 2, that's fine, but you're kind of overcomplicating things. So negative 2x times 7 is negative 14x. 7 times 15y is 105y. You just got to keep it together when the numbers get big. Negative 32 times 7 is negative 224. And on bottom, 7x times 2 is 14x. And then that's a negative 5y times 2 is 10y, so minus 10y. It's going to be a negative in a bit. 17 times 2 is 34. Then again, I always prefer to add. Now right away the x's are opposite. One's negative, one's positive, so I don't need to change the signs like I did up here. Okay, those already cancel out. Then I take 105 and add negative 10. That's going to be 95y. Then I take negative 224 and add 34, that's negative 190. And then I can just divide, and that gives me my solution for y. So I take negative 190, divide by 95, and that's going to be negative 2. So y is negative 2. Okay, then again, I like to roll with the original top equation. So negative 2x plus 15y equals negative 32. You can use that, this, or this. I would go with one of the two originals. Y is negative 2. So I replace y with negative 2. So I've got negative 2x plus 15 times negative 2 equals negative 32. So we multiply, we find the product of 15 and negative 2. Well, that's negative 30, so we got negative 2x, either minus 30 or plus negative 30. It doesn't really matter, you add in either instance. Negative 2x equals negative 2, then I divide by negative 2, and negative 2 divided by negative 2 is 1. Okay? And this is the third and final method, okay? There's 3 methods: graphing, substitution, elimination. Okay? At least there is in my book. 3x plus 2y equals 17. 2x plus 5y equals 26. Then once you get the hang of it, the process kind of comes repetitive. One thing you got to watch out for, let's say instead of, don't change the problem, but if that was already a 2x and a 2x, I'd just change the signs on the bottom and do it right here. I wouldn't have a need to multiply. But since the x coefficients are not the same of any kind, the y coefficients aren't the same, we're going to have to do some multiplying. The multiplication, what I'm doing when I do these dot, dot, dot is applying the multiplication property of equality to the equation. So you have a 2 here, so 2, 2, 2, 3, 3, 3. So we're now going to have 6x plus 4y equals 34, and then 6x plus 15y. 26 times 2 is 78. 26 times 3 is 78. Okay, we want to add these together, but 6 and 6, we can't cross those out. That adds to 12. But if I go negative, they're gone, but then we have to make our 15y negative and the 78 negative. So if we're negative 15, I add those, that's negative 11y. 34 and negative 78, I'm going to add those, that's negative 44. So I divide by negative 11, and y equals 4. Okay, now let's get the x. So 3x plus 2y equals 17. Again, I have my solution for y, so y is now 4. So I find the product of 2 and 4 before I solve for x. That's 8 equals 17. Then I minus 8. That takes me to 3 times x equals 9. And then it's academic from there, dividing by 3. So 3 and 4. Okay, next one. Negative 5x plus 9y equals 43. 3x plus 8y equals 68. Okay, so right now negative 5 and 3, 9 and 8, we got to somehow match them. Okay, so I'm going to times, I'll times the top by 3. Now you can times the bottom by negative 5. I personally prefer 5. Okay, I don't prefer to do negative multipliers in this portion of the problem. Negative 5x times 3 is negative 15x. 9y times 3 is 27y. 43 times 3 is 129, I think. I'm pretty sure it is. Yep. Sometimes I'm not real confident in my mental math like some people are. So 15x plus 40y, 68 times 5, 300, 340, I think. Okay, I'm going to double check that. Yep. Now there's no need to do the sign change because I already have the negative 15, positive 15 combination I need to cancel those. 27 plus 40 is 67y. Then we'll be taking 129 plus 340, and that's going to be 469. Then I divide by 67. That's 7. Okay. So y is 7, okay, and then I would use the top one, negative 4x plus 9y equals 43. And we have our y solution as 7. So we have negative 5x plus 9 times 7 equals 43. 9 times 7 is 63. So negative 5x plus 63. 43 minus 63 is negative 40. Divide by negative 5, and x equals 8. So 8, 7 is a solution. Okay, next one. 2x plus 6y equals 18. And then we have x plus 3y equals 9. Got 2 more left here. So I could apply a 1 there and multiply it by 1 up here, or you could just leave it the same. It isn't going to change it. And then 2. So the top really just doesn't change. 2x plus 6y equals 18. Now the bottom, 1x times 2 is 2x, 3y times 2 is 6y, 9 times 2 is 18. Well, what have we here? You're going to see, okay? Okay, let's make that a negative 2. Those cancel. Negative, negative. Well, here's the thing. The y's will cancel along with the x's, so that whole side's just 0. Don't write y now, okay? That because you writing a y there is telling me, okay, 6 plus negative 6 is 1. It's not, okay? It's 0. 18 negative 18 is 0. Well, then I don't have to worry about that. 0 and 0 are equal, so that's an IMS, infinitely many solutions. Okay, now next one. Negative 2x plus 5y equals 7. Negative 2x plus 5y equals 12. Okay, dude, there's no need to multiply. We already have at least, they don't add to 0, but they're at least the same coefficient, okay? So I'm going to do my thing right here instead of here. Now I need 1 a negative, 1 a positive, so if I make that positive, we're good. Negative, negative. Well, again, the y's will cancel along with the x's. 7 plus negative 12, though, is negative 5. 0 is not equal to negative 5. That's a no solution. Okay. All right. And that's the third method. We're going to do story problems then after this.